Hello, my dear student. I am Archita Chakraborty, lecturer in electrical engineering of Sri Ramakrishna Institute of Science and Technology. Today, I am going to discuss about the construction of single-phase transformer. So, at first, the different constructional parts of a single-phase transformer. So these are the basic components of a transformer, or you can say these are basic common constructional parts of a transformer. So number one is the laminated magnetic core, windings, insulating materials, transformer oil, tap changer, conservator, breather, cooling tubes, Buchholz relay, and the last one is the explosion vent. So before the deep study, we have to analyze the constructional view. You can see here the constructional view of the core of a transformer. It is a three-phase transformer core. If it is a single-phase transformer, then there are two limbs. You can see here, this is the limbs. Here it is a limb. There are three limbs. In case of three-phase transformer, there are three limbs. And this is the laminated core or laminated magnetic core. And this is the primary winding. And this is the secondary winding. So that is the construction of the core and winding. Now you can see here the total constructional view of a transformer. So here it is the conservator tank or oil level gauge. This is the conservator tank where the vaporized oil is stored. This is the HV and LV tank covered bushing. So this is the insulated bushing where the terminal of the high voltage conductor and low voltage conductor are connected, or the terminal of the high voltage winding and low voltage winding is connected with the external conductor or external wire. This is the on-load tap changer. By this tap changer, the tapping of the winding can be changed. This is the tap changer oil level gauge. This is a tap position indicator. You can see the position of the tapping by this indicator. The on-load tap changer motor control and drain sample valve. And you can see here also the silica gel breather. The silica gel is used in the breather to absorb the atmospheric moisture, and at the most outer part there is a control cabinet. So this is the constructional view of a transformer. Now the laminated core. The core of the transformer is used to support the windings, and it is made of soft iron to reduce the eddy current loss, or you can say it is made of high permeability material, that is like silicon steel, germanium steel, etc., to reduce the eddy current loss and hysteresis loss, and provides low reluctance path. So what is reluctance? Reluctance which resists the flow of magnetic flux. So due to uses of this high permeability material or the ferromagnetic material, the reluctance is reduced. The diameter of transformer core is directly proportional to copper loss and inversely proportional to the iron loss. So if the diameter of the core is increased, then the copper loss is increased and an iron loss is reduced. So this is the laminated core. Now the next slide is a winding. So windings consist of several copper coils, turns bundled together. Winding means when several numbers of coils are connected in series, that is called a winding, and this is bundle, and each bundle connected to form a complete winding, and each bundle is formed and winding, and winding can be based either on the input or output supply or on the voltage range. So according to the voltage range, the winding can be classified. One is high voltage winding, which has more number of turns, and the low voltage winding, which has less number of turns. Winding that are based on supply are classified into primary and secondary winding. When the supply mains is connected with the winding, then this winding is called the primary winding, and when the secondary or the winding which is connected to the external load circuit is called the secondary winding, meaning the winding to which the input and output voltage is applied respectively. On the other hand, windings based on voltage range can be classified into high voltage and low voltage winding, which I have already told. So these are the winding of a transformer. Now the insulating material. So insulating material like papers and cardboards are used to isolate primary and secondary winding from each other, as well as the transformer core. In actual practice, in the nearer to the core, the low voltage winding is installed, and above the low voltage winding there is the high voltage winding is installed, and between these two winding there is a high voltage insulation, or the paper or cardboard insulation is provided, and it is also provided between the low voltage winding and the core. These windings are made of copper due to high conductivity and ductility. We know that copper has high conductivity, so these windings are made of copper. High conductivity minimize the amount of copper needed and minimize the losses. So when we are using copper, we know copper has a high conductivity and low resistance, so the I square R loss or copper loss is minimized. Moreover, high ductility results in easy bending of copper. Actually, copper has more tensile strength, so it cannot be broken when the coil or the winding is made, so it is used. And so due to high ductility result in easy bending of conductor into tight winding around the core, that also minimize the amount of copper. So this is the insulating material which is used in the transformer winding. Next, the transformer oil. This is the very important part of a transformer. The transformer oil insulates as well as cools the core and core assembly. Actually, this is an hydrocarbon oil, or this is known as ascaral oil, and this transformer oil insulates the winding, and also when the load is increased, then the windings I square R loss is more. That means the copper loss is more, and then it being heated, or due to the eddy current loss, also the transformer core is also heated. So to cool the transformer, this type of oil is used. So the properties of this type of oil is, it is a good insulator, so it has a good dielectric strength, high dielectric strength, and high flash point, okay, and cooling property. So the core and windings of the transformer must be completely immersed in the oil that normally contains hydrocarbon mineral oils. And as I have already told that the name of the oil which is used in the transformer is ascarol. Now the tap changer, or you can say the on-load tap changer. So to balance the voltage variation within the transformer, tap changer are used. These are two types. One is on-load and one is off-load. So in maximum case this on-load tap changer is used, and rarely this off-load tap changers are used. In all on-load tap changers, tapping can be changed without isolating transformer from the supply. So when it is in loaded condition, if we want to vary the voltage, we have to use the on-load tap changer without isolating the transformer from the supply mains. And while in off-load, the transformer needs to be disconnected from the supply to change the voltage or to regulate the voltage. So that is the tap changer. Now the conservator. The conservator is an airtight metallic cylinder drum fitted above the transformer that conserves the transformer oil. So when the heat of the transformer is increased, then the oil is vaporized and then the volume of oil is increased. And to store the vaporized oil, this conservator is used. So it is vented at the top and is filled only half with the oil to allow the expansion and contraction during the temperature variation. So however, the main tank of the transformer with which the conservator is connected is completely filled with the oil through a pipeline. So when the volume is increased, then the transformer tank is completely filled, and to reduce the oil pressure in the transformer tank, this vaporized oil is supplied through a pipe to the conservator tank. So this is the conservator. Now the breather. Breather is mainly used for breathing purpose. It acts like a nose of a transformer. So the breather is a cylindrical container filled with silica gel, which is used to keep the air that enters the tank moisture free. When the load of the transformer is increased, then the transformer oil is heated and the volume of the transformer oil is increased. Then the air which is in the transformer tank is flowing through the breather or exhaust through the breather to maintain the atmospheric pressure. And when the load is reduced, then the volume of the transformer oil is reduced, and to fill the air gap, the atmospheric air is entered through the pipe or through the breather. So when it is entered through the breather to maintain the atmospheric pressure, the moisture which is present in the air is absorbed by the silica gel. So the actual color of the silica gel is mainly blue. When it is saturated by water, the color of the silica gel is converted into pink. So this is because of the insulating oil, when reacts with the moisture, can affect the insulation and cause internal fault. So we can't allow the moisture, which is why it is must to keep the air free from moisture in the breather. When the air passes through the silica gel, the moisture content are absorbed by the silica crystal. And when the color of the silica gel is pink, then we have to replace it by the dry silica gel, which have the blue color. Now the cooling tubes. As the name suggests, cooling tubes are used to cool the transformer oil. The circulation of oil within the transformer may be natural or forced. In case of natural circulation, when the oil temperature rises, the hot oil naturally moves to the top and cold oil moves down. Due to the difference of volume, the volume of hot oil is less than the volume of the cool oil. While in case of forced circulation, an external pump is used to flow the oil through the cooling tubes. Now the Buchholz relay. It is used as a protecting device, or it is used as a secondary protecting device of a transformer, and mainly it is used above the 750 kVA transformer, or in the generating substation these Buchholz relays are used. It is placed between the conservator and the transformer tank. So placed over the connecting pipe that runs from the main tank to conservator tank, the Buchholz relay senses the fault occurring within the transformer, and it operates by the gases emitted due to the decomposition of transformer oil during the internal fault. Internal fault means if there is an insulation damage in the winding occurs, then this Buchholz relay trip the transformer from the supply mains. Thus this device is used to sense and in turn protect the transformer from the internal fault. Now the last slide, or the last constructional part, is the explosion vent. The boiling hot oil from the transformer is expelled during internal faults through the explosion vent to avoid the explosion of the transformer, and this is generally placed above the level of the conservator tank. So that's all about the constructional parts of a transformer. Thank you.